was a bit of a disastrous beginning. Just deal with it, I guess. Alright, so I had a couple streams earlier regarding pi and all that kind of stuff. I did want to touch on something with that. That's actually a movie. I got my notepad handy. I probably don't have a pen. I do want to change up this music though. I want something a little bit more. I really don't want to play that. No. Let's just mute that. Something a little more active here. Let's try this one. That's dark ambient stuff. Pretty cool. Anyway, yeah, we could probably listen to that for a bit. I'm into the dark ambient and Nimbus crap right now. Alright, let me set up my webpage, my stream and all that. And we're gonna dive deep into some number, well, supposedly some number crunching, but... So there's a discovery I made. I guess the Fibonacci sequence is related to the golden spiral and phi. I've kind of studied these geometric symbols, and they're like sacred geometry symbols and stuff like that. I haven't really delved into it a lot, but just enough to kind of wet my whistle, so to speak, I guess you could say. It's all interesting, and there's a relationship to some of this stuff as to, you know, what I'm getting into. I'm like wanting to create an area. Basically, all I'm wanting to do is create an area of infinity, focus in on that area of infinity, and manipulate that area of infinity, and use light to do it, and focus in on areas that are at or near infinity around these light patterns that I'm working with. Now, you don't really have to create what's called strange attractors to do it. But it's helpful to understand a little bit about what strange attractors are in chaos theory and stuff like that. I really don't want to get too much into it because it might be kind of boring. But I mean, it is what it is because that's basically what I'm studying. So we're just going to talk about the numbers and the geometry, and the fact that, oh, what the hell was that? My lovely my lovely face is not in the picture yet. We're gonna have some FaceTime here, and we're gonna have some website time. Let's see. So we get rid of this. We get rid of this. Hello, that's my head right there. That's my hat, actually. And then we're gonna do this right here. All right. So before I get into that, basically, what like phi and pi and some of these transcendental numbers were actually used in constructing the Great Pyramid. I don't really have, well, there is actually an image. There's an image I have, and I want to bring this image up here. Let's see. So we've got this image, and let me fix it because it's a little bit discombobulated here. I took this picture off of a website so that we could take a look at it and find out exactly what's going on, if that is even possible. So if you look at the picture down in the lower left-hand corner, I was actually looking for this rectangle setup in order to figure out the relationship between the rectangles and phi. And there was another website. I wonder if I have that website. Let me just try to see if I can find it here. Okay, it's this one right here. So they're talking about if A is 161.8% of B, and you've got A equals B plus C, and you've got A divided by B equals B divided by C, okay? Now, so far, none of these calculations deal with square roots. This percentage I'm looking at is kind of weird. It's making an assumption that you already know the value of phi. Which in the calculations, it talks about this number here. Using the square root of an integer. We could, if we had a graph, there might be an online graph formula that we can do this, because there is actually a graph of phi. It's 1 plus the square root of 5 divided by 2 plus 1, I think, or something like that. But if you look at the picture down in the lower left-hand corner, you can see the chord. It's called a chord. As it goes around each of these boxes, it's building this golden spiral. And the picture up at the top is saying, discover the fascinating concept of the golden ratio, and they're using, okay, I don't understand that, because 21, oh, it's a Fibonacci sequence, not prime numbers. And it makes me wonder about what other numbers can fit in there to come up with something, you know? I'm talking about this dampening wave, how it starts from a point when it reaches a certain number. I'm a little bit thirsty and hungry. That's why I'm not jibber-jabbering. My microphone's low too. So probably you have an area under the square, or better yet, you've got three lines. You've got A, B, and C, or you've got A and B actually. And if I were to go back to the website, which is here, we got A equals B plus C. Now I don't know if that relates. Because you're actually looking into the future here. Okay, you're kind of looking into the future. But you've got B and C, and you've got A equals B plus C, which I don't see that in this particular use of that formula. But you can see that in the graph, A is longer than B and C, and so on and so forth. But they're using a different formula. They're saying A plus B over A equals B plus C over B equals C plus D over D, yada, 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 yada. If you look at this, 161% is like 66%. It's not quite 66%. And how about you take your viewer bot and shove it up your A double you know what, because I'm going to do something for it right now, and we'll just ban you. If I can find the stupid thing here. Yeah, we'll find it soon enough. I have to log on there to do it. Goodbye. I don't even know what the hell that was. I don't even know what I'm doing here. Because I'm supposed to be over here, but it's, for some reason, I don't know why this is like this. Everything got messed up here for some reason. Bear with me, I'm fixing my stupid stream here. It's not really stupid, but yeah, you know how it goes. Alright, let's bring up that web page again, because now I've lost it. I'm just gonna set it over here. Wait, were we looking at the web page? So, you know, I don't really know. You know, in this upper picture, they're saying that those numbers might represent the arc. You know, the arc around the box instead of the straight line. If that's A, B, and C, A does in fact equal B plus C in that picture up there. No. What if there's another series of numbers that's different from the Fibonacci sequence? Let's go there and look at it. I'll take this out. Uh-oh, what did I do? Took me out. What's that image? Here they've got different numbers, but they still add up, right? So here it says Fibonacci sequence in which each element is the sum of the two elements that precede it. Precede it, like it's going in the forward direction. And here we're going like kind of backwards, I guess, into time. So 8 and 13 is 21, 8 and 5 is 13, 5 and 3 is 8, and so on. But the numbers are getting smaller. So what I want to do is create an idea that uses only integers, in which this case it does. And how the number of phi comes into this. Fibonacci numbers are also strongly related to the golden ratio. Bennett's formula expresses the nth Fibonacci number in terms of n in the golden ratio and implies that the ratio of two consecutive Fibonacci numbers tends to the golden ratio as n increases. There's another thing called Lucas numbers, which obey the same recurrence relation and with Fibonacci numbers form a complementary pair of sequences. So it goes on, and it goes on with these numbers here, which looks like they get eventually quite big for some reason. These are the first 24 numbers. Now, if you're building something like the Great Pyramid, you know, I don't want to go into the entire deal about the Great Pyramid itself and the dimensions and everything like that. I'm going to make some assumptions and so on. Just trust me, it's there. I'm looking at formulas and I'm wondering about the possibility of let's go here. Let's try something. Formula calculator and graph online. Let's see if we can find something. A graphing calculator. Is that the one that's got that stupid? Okay. We want to add an expression. No, that does not help, does it? Why is there an a sub 2? I don't like this graph. Let's see if we can find another one. Oh, what's this? Usually they'll give you some formulas to play with. What's this here? Alright, that's not gonna work out for me. Let's try another one here. What we want is this formula, f to the minus n equals f minus 1 plus. That's like a programmable. Tools. Let's try, I've got a TI-84. Oh, this one's in dark expressions. Oops, I just lost my expressions. What if I can do... Shit. What's this? Oh, I can't see the damn letters because they got it in black. Oh, I can see them now. We've got A plus B equals C. Let's try C equals A plus B. What the fuck? Oh my god, what the fuck is going on? A plus B. Now I want to make another formula, but how do I do that? Add expression. A divided by B equals B divided by C. A divided by B. What the fuck is going on? Are you fucking kidding me? How the hell do I do division, for crying out loud? It won't let me do division. I don't know how to do division. Oh my god, what the fuck? Look, I can't even get out of this fucking mode. Greek letters. I don't need Greek letters. There's a lambda. Delta. Why isn't the divide sign in? It's supposed to be a regular freaking calculator. Absolute values. This is fucked, man. I don't know how to do it. I can't even get back to where the fuck I was, you know? I can't get out of this fucking mode. There's no division sign on this keyboard. It's a slash. And when I do that, it just does something weird. I don't know what to do. Let's insert a function. Math mode, text mode. A divided by B equals B divided by C. Add a table. If I do this, I don't know how to do it. This is the same bullshit here. Custom scripts. Expression formula, etc. Programmable calculator, etc. Basic arithmetic, scientific calculator. Wait. Custom variable formula. Variable X. Expression or formula. So when I look at this graph, when I look at this, it says, oh, when I go to the other web page for calculating phi, it says A divided by B equals B divided by C. So A, no. Oh, you see what they've got here? They've got this different. A is the long number. A also equals 1 over C. No, that's not right. C, if you multiply by both sides, you get CA over B. I gotta do this on paper. And I don't have my fucking pen. I swear to fucking God, I can't do nothing, you know? Wait just a minute. Wait a minute. I gotta get some of my shit. Oh, I don't fucking know. I got so much stuff here. Working with this project is, it's becoming somewhat draining. Oh, we got a pen. God damn. Alright, so I'm gonna write this down. So I've got A equals B plus C. A divided by B equals B divided by C. So if we multiply both sides by C, we've got CA over B equals B. Multiply both sides by B, we've got CA equals B squared. And then, so C equals B squared divided by A. Substitute that back into the formula. A equals B plus B squared over, oh, that's not good. A over B equals B over C. So you get CA over B equals B. CA equals B squared. Oh yeah, okay, so B squared equals, oh fuck, that's not gonna work either, is it? B squared equal, no, A equals B squared over C. So now you have B squared over C equals B plus C. So now if we go multiply both sides by C, you've got B squared equals B times C plus C squared. to take the square root of that number. If I, well, I can't do that. We got a value for b squared, but that doesn't fit in the term. If you take the square root of that, which we don't want to do. Oh, so you can't do that. You can't substitute. You can't do substitution then. Because if you do substitution, you end up getting a square root. So we've got to maintain this double formula here. Let's see if we can. Let's see. That's x. I don't know if I can do this or not. Let's see. A equals b plus c and a divided by b equals b divided by c. Well, they've got variable x and y. If I, let me think. I gotta think a minute here. So, A, B, C, A, B, C. So if we look at the picture, where the hell did I see the picture now? Oh yeah, over here. Fuck. Oh God in heaven. Oh, in terms of x and y. So A, B, and C are actually lengths of a hypotenuse. So you've got Z could be the hypotenuse, which is A, and then B and C are x and y. So that means you've got Z equals x plus y, and Z divided by x equals, well, I've got A over B and B over, so that would be x divided by y. Let's say that x is 3, y is 4, and z is 5. I can't even get the damn... Yeah, I don't know what's going on with this stupid thing either. Oh, you do reset? What the fuck? Oh my fucking god. I don't know, I can't do it there. I don't know what's going on. Let's see here, let's try this one. I want to do multiple. Let's try this one. Function 1 z equals x plus y. Function 2 z divided by x will it do that? I've got to give values. Use it in my functions. God, this is so fucking bullshit. What's this? (2D) function. Y range. It's not doing nothing. It's fucking garbage. Oh, what's this? Wait a minute here. The thing we have to substitute. I don't know. Here's one with a divide sign. But can I... Okay, so... function... This is this other... Same thing that was on this other freaking web page. Function z equals x plus y. Input. We want to add another expression. So z equals z over x. So it's going to be x squared divided by y. Input x equals 3. Y equals 4. Equation 1 equation 1 Why is there an A there? What the fuck is this A? I have no fucking idea what's going on. Oh, the name is F. If x squared over y equals that, if I say x squared, I think I'm gonna have to say x squared, maybe. So this would be x squared, and you multiply that times z y x y x times y plus y. Oh my fucking god, what just fucking happened? X equals 3. I don't know what to do. Why? Because it's got that weird term. How the hell do you solve for the fucking... Oh, hello. What happened here? I don't even know if this is fucking right. What have we got here? That's obviously going up into infinity. That's a straight line. What if... But how do we know this is even right, though? If y is 1... and x is... No, if x is equal to 1, let's say... and that would imply that doesn't work. You have to solve for this equation. You've got 0 equals minus x squared let me see something here. If I subtract x squared from both sides, you get... Shit, I don't know what to fucking do here. I don't think I'm gonna be able to do this shit tonight. God damn it. I can't get off of that. If x equals 1, that becomes a 1 plus 1 times, I don't know what to do. I can't do it. Exponential and logarithmic, you've got this. No, I'll have to have a program. I'd have to write a program. You say, okay, x equals 1, then you run a list of what y is equal to. I'll tell you what, I'm just going to jump to this Fibonacci sequence, and I wonder... See, all these preceding numbers, if you add them, they add up to the next number, okay? So if we were to take these numbers are C, B, and A, okay? C, B, and A. Why this sequence of numbers, though? There's tons of other sequences of numbers. This is an example that goes off into infinity. But the numbers get quite big as you go along here. I want to look at this. I want to look at this here. Used to find coefficients of the expansion a plus b to the n in the n plus 1 row, etc. This a squared plus 2ab plus b squared, it's very close, isn't it? Because you'd have x squared plus 2xy plus y squared. It just has that 2 in there. So it's really close. As 1ab plus 2ab plus 1ab. So it's using that's a squared. Equivalence can be found in the third 2 plus 1 row. Its current term is equal to the sum of the first 8 terms. Thus the formula is this. When diagonal lines are drawn across Pascal's triangle, the sum of the numbers that each line crosses is a term in the Fibonacci sequence. Huh, the Pascal's triangle is just the opposite of the Fibonacci sequence, and they're both in the same damn triangle. Oh my God. That is 16, 20. No, it's supposed to be 21. Oh, it is, because the 1 is down here in the bottom. No, it goes to the next sequence. Oh, it skips every sequence in the 1 section. So it's the next one's down here. That is just a coincidence. It's just it's too crazy. One, two, three, four, 5, 6. If you look in the opposite diagonal, you've got 1, 2, 3, 4, 5, 6, and you got 1, 3, 6, 10. What's that sequence of numbers? That's 1, 2, 3, 4, 5, 6 in the other direction. This is 6, 10, and 15. 6 plus 4 is 10. 10 plus 4 is 14, or 15. It might be you add the number and then you add plus 1 each time, plus 2, whatever the hell it is. I don't know. I'm losing time here. I was thinking 2/3. Okay, so let's say that A equals 3 over 3. Then you've got 3 over 2 equals 2 over 1. That's not true. A is to B as B is to C, where A is 161.8 of B and B is 161.8% of C. It doesn't go by 2/3. I guess so. What I wanted to do is if I look at this, where is it? If I look at this relation to the golden ratio, algebraic visualization of the golden ratio and its conjugate. Golden ratio phi and its conjugate, whatever that is, as the solution to x plus y equals 1 and x times y equals minus 1. So these are integers divided by an integer. This is a dampened wave, okay? What did it start out with? If I use one of the bigger numbers, no, I'm trying to figure out, what am I trying to figure out? Phi, right? So how does that even... I'm slow, but that's just the way it goes. Lines of consecutive quotients. The ratio of consecutive elements in this sequence shows the same convergence towards the golden ratio. The resulting recurrence relationships yield Fibonacci numbers as the linear coefficients. This equation can be proved by induction on n is greater than or equal to 1. So these are like, so on and so forth. Fn plus 2 minus Fn plus 1. This is because Binet's formula, which is written as thus, can be multiplied by thus and solved as a quadratic equation via the quadratic formula. This is using matrices. Those are prime numbers, etc. Computer sequences. Fibonacci tree of height 6. Nature. I don't know. If I go back to this picture, you see that there's an arc. There's this arc, and each one of these arcs is called a chord, and each chord in and of itself is part of a circle. And that angle is 90 degrees each time. Yeah, this is, it's probably not giving me the answer I need. Because I don't even know the question. Measuring pi, squaring phi by, let's look at this article and see if we can glean any information. Lear's foundational claim that pi equals 4 divided by the square root of phi relies heavily on his first geometric proof, which he entitled Geometric Proof for the True Value of Pi, so on and so forth. Three 3.14159, 3.142. So that's like 0.02 off of this. Now ask yourself, I want to listen to something else. That's a little better. Let me think here. So, getting back to pi and this sine wave. I'd have to write my own computer program in order to investigate phi a little bit more, but I don't have the time to do that. So, when we have a circle, we know that the circumference equals 2 pi r. We know that the area of a circle equals 4 pi r squared. If we say that pi if we say that pi equals c divided by 2r, and the area equals 4 times c over 2r times r squared. And then you've got 4 times cr over 2. The area is related to the circumference by 2cr. If the circumference equals 1, you don't know the radius though, do you? What if we did it in terms of... Jesus, what the hell is my... let me think here. So if I make a square... I'm not sure if we go... If we go outside of the square... I'll bet you. Now a chord is related to... let's see here. A chord is related to a circle. But exactly how is it related? And how is it depicted in this picture? So the chord length is going to be a Fibonacci number. Where the hell was I here? got this. Chord length is 2 times r times the sine. What is this? The sine of theta over 2. Diameter is also considered to be a chord of pairs of the size. Diameter. Perpendicular to a chord is drawn from the center circle, bisects the chord. Chord length used during the perpendicular distance from the center equals 2 times square root of r squared minus d squared. The fuck? So it's taking one point of that chord, which in this case, if it's inside of a circle, let's say that the circle, these are squares. These are definitely squares. I thought they were rectangles, but this is a Fibonacci sequence. And that Fibonacci sequence comes from the diagonal. I thought they were rectangles. I didn't think they were squares. So you've got the center of the circle. I wonder if the center of the circle is this other point down here. It looks like it could be. You know what? It is, actually. If you look at this, you can't see it right now because I don't have it up here. Let me just bring it up, my picture-in-picture thing. What is it, big view? And that's not it. Wait, So if you look at this picture, the circle is inside the square. That A curve is inside the square. So that means, so yeah, I was relating to this. So this is actually inside the square. So let me go ahead and make this picture. Oh wait, it's over here actually. But it's actually the entire... Okay, so it actually starts over there, doesn't it? So the radius extends out to the circle. A is a 45-degree triangle in each one of those cases. So if let's use the right one because this is going to be a proportion. I can see that. Let's just use the right one. We'll make another square. And then we draw this line out to here. And then we draw this line here out to here. And then we draw this line 0 out to here. And this over here is 45 degrees. hypotenuse, which is the long one. We've got theta. So if you look at the smaller one, I'm looking at B, all right? I'm looking at B, and the chord runs here. I see what the diameter is. The diameter is a point on that circle. So let me do another page here. I sort of don't know what I'm doing, but I do know what I'm doing. I just don't know why I'm doing it. So we've got a square like this. Make it bigger. We've got a chord. And we've got this. So it just so happens that that number is actually R. No, that's R. And we've got a 45-degree triangle that bisects that. So that triangle, where the hell? We know what the length of that line is. We know what B is. So let's say B is, we know what that is. So we're actually taking, let's say, we'll call it F. F equals 1/2 of B, all right? And F is going to be, when you do the right triangle, it's actually not that. It's supposed to be 1/2 BH. Or that's the area or some stupid shit. I don't fucking know. All I know is that this is 45 degrees. That I do know. And we've got, that's going to be 1/2 of R too. So you've got X, Y. Oh shit, no, you've got, fuck. Well, I'm just gonna make it Z. I don't know if this is gonna fuck me up or not. So Z. So that's 1/2 of a Fibonacci number is what that is. But that's the other side. That's the other side of the 45-degree triangle. So actually, it's the same distance as this other line. So Z equals 1/2 of F. F is the Fibonacci number. We know that number, and we know theta. So what we're looking for, I'm thinking I want the length of the arc, is what I'm thinking. I just don't really know. What if I didn't need to know the length of the arc? What if I used... What if I started from the origin? Remember they said that number was 1.618? Like, it kind of goes... I mean, if it started at 0... Where is 1.618? Is it an X number? Is it a Y number? It's the length of that line. We can actually use half of the length of the line, I'll bet you, and come up with the same sequence. Because each one of those angles is always 45 degrees. And we've got a radius. The radius, we don't have so the box is not the if I use a triangle of 3, 4, 5, z equals 5, y equals 4, and x equals 3. No. Wait, yes. Then R equals 2 times x. So now we've got a radius of 2 times the value of x, which is 3. That's a radius of 6. So each time that thing goes around, that doesn't cut, that line doesn't cut in half. It cuts by 61% or some, whatever the hell that number is, right? 61.8%. So the square must also do that. That's the area. The line all right, let's go back to this 3, 4, 5. I've got 45 degrees. I've got a radius. So if I take and make a triangle, no, I can't make it out to that. It would be smaller, wouldn't it? The right triangle formed by running the radius up to the midsection is going to move this line. So the line, so R, let's say R is 6, and then it goes down to some values, say it's like 5.3 plus minus, and then we draw another line, make it dotted. That's an X and Y number, but we don't know. It's 45 degrees. We know 45 degrees. We know the radius. Oh, so Z equals the radius. No, yes. Okay, so then Z equals R, which equals 6. So we've got a value for Z, because it's the radius. We don't have a value for the bottom number, but we do have a value for theta. So the, oh God, it's going to go into, no, the arc cosine. So, so I'm going to call this R sub C equals, so when you do trig, it's the opposite of the hypotenuse equals the sine. We don't know that. Oh, wait a minute, can I calculate that one? I've got theta and I've got Z. That's going to be, those numbers are going to be equal to each other. So I can do sine minus 1 of theta equals, this is going to be y over R sub C. We know R, so R sub C, god damn it, what the fuck. The sine of that would be 0.45, and is that a percentage, I wonder? God, this is fucked, man. I thought I've got a value for this, and I've got a value for Z. So why can't I find X and Y? sine of theta equals y divided by z, and z equals r, okay? So it's the sine of theta times r equals y. There it is, right there. It's right fucking there. It's right there. So the sine of theta, now I don't have a calculator, I think it's 0.707. This is a square root number, which I hate to get into square root numbers, but, and sine is kind of based on, you got your pi again, which me personally, I'd rather have cake. Alright, so we go sine 45 degrees. And it'll come up with, no, that's not fucking right. Fuck. That is not fucking right. Why the hell did they give you that number when it's this number here? .7071. We're going to go to 4 decimal places, all right? So now you've got 0.7071 times 6. .7071 times 6. So now you have a value for x and y. It's 4.2426. Okay. Now, what we can do is we have an ordered pair. We'll have 2 ordered pairs. The other ordered pair is going to be 4. Okay, so it's 4, 4, and this one. So we've got 4. All right, so what we do is we'll take this and we're going to divide this by 4. Oh, wait, I did something wrong. 4 divided by 4 point... I fucking forgot what the number was now. That doesn't have a memory, does it? 0.7071 times 6. So that actually becomes a 7. It's closer to 7. 4.2427. 4.2427. This is not right. The fuck? Minus... .7%. Yeah, 5.72%. So if I do 4 times 5 point... Oh, fuck, I don't even know what the number was, damn it. Fuck, that's percentage. 4 times 0.0527. Oh, God. It's 2108. So minus 1. So it becomes 5.720. 5.72. So 4 times 0.0572 equals plus 4 equals. That's not right. That percentage is not right. What the fuck is going on with my numbers? I mean, I'm trying to figure out the damn... You subtract the numbers and divide it by 100? You go minus 4, and you divide that by 100. No, you multiply... No, that's not right. 0.002%. Oh my fucking God. 4. It's 0.2427 over 4. But what's the percentage increase? If I do 1, that's 25%. So 25% divided by 4 is approximately 6.25. So it's close to 6%. Now how the hell do I get that number? 0.2427. I don't know. I don't know how to fucking do my goddamn percentage. Pardon the cuss and swear, but this is not good. If I go from 4 to 5, alright, that's a difference of 1. If I do 1 divided by 4, it gives me this number. Okay, so that's a 25% increase. So you multiply that number times 4, and you get 1. You know what I gotta do? That's what I gotta do, because I just can't think now. It's fucking music. So 5 minus 4 is 1. And then I divide it by 4. So 4.2427 minus 4 equals divided by 4. There it is right there. There it is, 6%. I got it. I got the number. So, the increase, the difference between the line and the chord, and I think it's going to be the same number each time from the looks of the graph. So the percentage, so from here, and you got this, and you got this, and then you've got this. percentage increase equals 6.0675%. So whatever that number from Z is, we can multiply that percentage for each number, and then we can come up with the value for we come up with the value for Y. Is that what I did? So I multiplied theta times 0.7, so sine theta times R because R is up here, and that gives me that value equals 6.0. No. Equals how the hell did I come up with a 4? Oh, I multiplied that times 6. This is actually 4.2627. Sine of theta times R equals 6. And, oh, it's the percentage of, no, it's this percentage here. It's this value because the x and the y equal this number when R equals 6. Where the hell is the 4? Oh, because it's supposed to be a 3-4 triangle, 3-4-5. What the fuck did I do? Oh, this is not, oh my god in heaven, fuck. This is not a 3-4-5 triangle. But it's 45 degrees. And R equals 6. So 1/2 of R is supposed to equal 3. It's not a 3-4. Oh, that part is not a 3-4. But this part here, this part here has to be a 3-4, doesn't it? Oh, no, it's not, because this is an equilateral triangle. Oh, shit. Oh, did I do, so it has to be, oh, fuck. Did I use the wrong numbers? Maybe I was supposed to use 1. I don't know what 1 is. because it's a right triangle. So if x equals y, that's 90 degrees. You know what? If I change that number, I don't think that's gonna be a right. Oh God, the fuck. I mean, that's an equilateral triangle. Or is it? If that length is 34, half of that is 17. And a squared plus b squared equals c squared. Then you've got the square root of 17. The square root of half of that number. I wonder if there's a Fibonacci number. Gosh. You know what? There is. It's 144. Because I think the square root of 144 is 12. I don't know what this number is. It might be wrong. I don't know yet. If I go 12 times 12 is 144. So there is a number up here, which I just freaking lost. If we go back to the picture, which I'm not really looking at right now, I gotta key you in on the picture. If we say that A is equal to 144, that would be the entire distance of known A. Would have to be half of that, wouldn't it? It says that number is 144. But then I'm going to have the square root of, is it 12? No. I've got x squared plus y squared, the square root equals 12. I don't think there's a number. But this is an equilateral triangle. Those numbers have to be the same. So it becomes 2x squared there's x times the square root of 2 if I square the values, I've got 2x equals 144 and x equals 144 divided by 2 is 72. If x equals 72, 72 squared times 72 equals times 2 equals, and then take the square root. Fuck. 2x squared equals 144. I think I did this wrong, because that becomes the same, I think. So you divide 144 divided by 2. You take the square root of 72. Okay. So you do that number. $8.485 times 2. Shit. Times 8.485 equals times 2 equals. I don't know why the fuck I'm doing this tonight. I'm dealing with this pi issue is what it is. So if we say that z equals r equals 144, it's 72 plus 72. So x equals 72, y equals 72. No, that's not right. X squared. X squared equals 72 because z squared is 144. So when you take the square terms right out altogether, then you get the number. So if that one number is 72, and then we try to find the other number, we take the sign and multiply. Sine is x over that. The arc sine is 0.707. So we go 0.707. And now the new radius is 144. And now that number becomes 101. Oh, that's a bigger percentage. What the fuck? minus divided by 144. 0.2929%. Point 0.293, 29.3%. So if you do 101 times 0.293. Oh, I can't do this tonight. I just can't fucking do it. Look at a radius. It's 144. Oh, damn it. You know what? It's not 144, it's 72. The radius is 72. It's the square root of 144. God damn it. That's 12. The radius is 12. Fuck. So, 0.7071 times 12. There's my new distance right there. 8 point. So from here to here. And from here to here is 8.485. Oh, god damn it, that's not the... Oh, yes, it is because it's an equilateral triangle, right? So the number I don't know is actually... Yeah, that's... I know Z, and I calculated that number. But I don't know the other number. So that number, then the other Z is half of that chord length. So if that number is 12, wait, that's 144? I'm so fucking confused. So I've got a choice. I can either set it to the diameter of the circle, or I can set it to here. But I can't do both. Well, it seems to me that it's supposed to be here. Then I can calculate this, because theta is still 45 degrees. I want to calculate dr, the percentage change of dr. Why do I want to do that? That percentage change is going to be the same all the time. Why the hell do I want to do that? It's the same percentage. It has to be. It's the distance of the hypotenuse that changes each time. Well, something else has to change. Ah. It's the side. The side changes, which is what I just measured. Remember they said something like 61%? Okay, so if I go back to the calculator, which you're not actually seeing right now. And if we take this number, 8.485 minus 12, now we've got this divided by 12, and there's the percentage right there. That's 29, that's like almost 30%, but it's 29.3% change. Each time. But that's not the change in the circle. Oh, you know, the change in the circle length, or the change in Z, that's the percentage that I need. And that number, no, that number's the same. It's the length of the side of the triangle. No, that distance R is different. Yeah, the distance R. Okay, so if I use 8.485, I can find out what the new Z is. It's the square root of 8.485 squared. All right, let me go back to the calculator. So we're going to do, remember this number, 2929. I don't need to remember that number. All right, so 8.485. And what we're going to do is we're going to square this times 8.485. Then we're going to multiply this number times 2. And take the square root. What the fuck? What the fuck? 12 times 12 equals times 2 equals square root of 2. $16.9. I did something wrong. I did the inside. But I subtracted that. I subtracted that difference. Oh shit, I don't know what that fucking difference is. I don't know what. That was supposed to be the fucking radius. You don't take half? It's half of the hypotenuse, which is 72. No, we wanted to use 144. So that means the hypotenuse is actually 288. So 0.7071. We're looking at the radius, which is the same as that, which we used 144. So it's supposed to be 8. So this value is 8. This value is 8.485. Oh, it's supposed to be the Fibonacci number. That's that total distance. Ah. So half of that number is 72. It's not the radius. It's this number. That number has to be 144. So half of that is 72. It's times 72. Fuck. 0.701 times 72. That's the height of the inside triangle. So that's actually the center coordinates, 50.9112. That's x and y. And now we've got x and y, and we've got to determine that number. Wait, the fuck. Okay, so times 50.9 equals times 2 equals. So we've got 5183.9. What the fuck? Yeah, it's because it's an isosceles triangle in both directions. Oh shit, it's 70. So that radius is 72. That's the inside triangle. Now the outside triangle is 144. And we want that length. Okay, so we do the same thing. We go 0.7071 times 144 equals. That's the outside length right there. One oh one 0.8224. What the fuck? That's almost a 50% change. Oh, that's close to that number, isn't it? We take this number minus, oh, wait a damn minute. It's 72. No. No. What the fuck? I got I've got the radius. The radius is 101. So that number No, it's supposed to be 144. So it goes from 70, goes from 72. Oh, I think I got it. I've got it. That's the difference right there. Because the radius goes up, it's 29.8%. It subtracts 29.8%. If you take that from 100, that's like 70%. That's a different number than that fee number. And each one of those numbers goes up and down. It either gets like longer or it gets shorter each time. It's not a linear approximation. It's a God in heaven is what it is. What the hell did I do? I was trying to figure out something to get rid of pi. Okay? I was trying to do a percentage. They did a percentage. They use percentages. Why do I come up with a different number, though? For all intents and purposes, it's 29.8%. So, I got 29.8% versus, which actually equates to a different number, minus plus 100 is 70%. 70.17621 versus, and then we go back to oh God. How the hell did I fucking see that? I think it's 61.8%. I think that's what it is. Versus 61.8%, and that's what they use in that damn formula, but I can't find. They started out with 144. If I made a box with that, So we got 144, we got 89 and 55. So this is 89. This is 55. The Fibonacci sequence is different. It's a nonlinear. It's a you know this is a derivative. This is a change. This is a change in R. dr over dt equals percent. The fuck am I looking for? I'm looking for that damn A plus B thing. It was that line. And I don't know where it is now. Yeah, I lost it, didn't I? Oh, wait, maybe it's I saved it, that's why. I think. Wait a minute. The fuck is it? Oh god, I lost it. I wrote it down in my project note. The fee formula. Here we go. There it is right there. So they're using 61.8%. And each of those numbers is the same. And I came up with 71.1762%. That's a percent change. That's got to be a derivative. It's a summation. Oh God, no. A is 161.7% of B. B is 161% of C. I think that percent has got to, but the change in the distance between the line and the radius is constant. The line is different. That number is not constant. That's the dampened curve that settles on a number. But each arc, why am I doing this shit? Each arc, the distance of the arc is going to be the same percentage change. What about the distance of x and y? It's not, that number is going to be different. I don't know. I just farted around with this all night, and I feel like I've got nowhere. What the hell? You know? It's almost like, why do I even bother? Go watch a movie and just call it, I guess. I have to go to work tomorrow, I hope. I'm looking at this picture. Let me go, let's try this here. I wanted to talk about strange attractors, and yeah, this is what I'm talking about right here. The only thing is they don't show the phase plot. I wish that I could see. Scale, constants. It almost looks like that basic attractor, doesn't it? This is a nice little program. Where's my... that looks like it's on a circle, on a sphere. Chaos is really cool to look at. It's, I wonder if there's another one now. Holy shit. Oh my god, look look how bright that is. Holy fuck. That is some shit, huh? Parameters, initial conditions. If you mess with the initial conditions, things can get really fucked up. This is your typical butterfly attractor. I don't know why the fuck it's kind of... Oh, it's going from left to right for some reason. Oh, you know what it's doing? It's rotating. Oh, these are different. Oh, these are different conditions with different settings. Oh shit, I just lost that one. There's the Cheops circuit, which I haven't been able to mess with yet. This is like a feedback loop in an electronic circuit. Holy shit, this has got a bunch of parameters. Oh, this Cheops circuit's not very good, is it? I'm not getting very good attractors here. What the fuck? Whoa. Oh, you've got to let it draw the picture. Okay, that's kind of sick. Holy fuck. that, my friends, is a strange attractor. So it's going through the iterations. It takes like 1,000 or more in order to find out, you know, if it's there or whatever. You have to sit and wait. So in these strange attractors, you know, you got these formulas and they add on to themselves, okay? The formulas add to themselves. And so, that's what it's doing. I mean, you can see kind of like a center point, right? So the center points represent where infinity is located. Now, if you're lucky enough to have a strange attractor that has a center point with empty space, that's where you want to do the investigation. Or you do the that'd be the best place. Or like this one is, you can see a circle in the middle, right? It's kind of empty in there. And it looks like 2 dimensions, but this is a 3-dimensional picture projected on a 2-dimensional plane. I don't know why it's spinning like that, though. So there's patterns in the chaos, and these formulas, they start with initial conditions, and if they're within the boundaries, they produce patterns like this that are within the boundaries. So not like the Mandelbrot set, though. I don't know. It's kind of cool. Yeah, it rendered it, but I guess it's not going to show it to me. I'm done for the night. I wanted to talk about this relationship between these transcendental numbers and chaos and the dampening factor, and these numbers having an initial condition and their phase plots. I guess they're phase plots, these diagrams. There's x, y, there's x sub t, y sub t, z sub t. They're all different phase plots of each dimension. There's 3 dimensions, so you go through each dimension and then you go through time. And in my design, I'm hoping to look at a 2-dimensional picture and have information that might be sent there, and over time you have to take like slices of the picture. You know, you see one picture, you take a picture, but you're not looking at it this way. Although I suppose you could. You have to look at it from a different point of view. If you think about it 3-dimensionally, I mean, I don't know how I would be able to look perpendicular to the light coming in, because it just wouldn't see it. You know, it's just going to be a line like this when you're looking down there. My infinity is flat up against the plane like this. It's flat. And if you look this way, into the plane, you're just going to see a line. It's just going to go up and down a line. You're not going to see nothing. and then getting from point A to point B to this line, it's going to be all fuzzy, and by the time it gets to the line, it's going to be a good point and everything, but by the time it gets you can't see nothing, you know? So I think you have to take pictures, slices in time, and then you take the slices and you co-add all of the pictures like this, and then you can rotate it and look at the picture as it's coming in. You know, maybe you'd have to change the time factor. You'd have to change, instead of doing it equally each time, you'd have to do it in a sense of 360 degrees. So you take one slice of picture, and then 10 seconds later, you start the whole sequence again, and you do it for a 360-degree rotation until you get the whole picture of the puzzle. I think that's what I'm going to be doing. And it's really got some relation to all of this, but honestly, why did I do this tonight? I have no idea. Let's end on a good note, yeah? Shall we? We'll just bring up some music, have a little meditation thing happening here, and just, you know, let's just go with, no, we're going to go with this one right here. Did I learn anything tonight? I learned that Pascal triangle has the Fibonacci sequence, and the Fibonacci sequence comes up with this value of phi, and I haven't really proven that. I'd have to write my own program, and I think that's what I'm going to end up having to do, is just write a graphics program to draw my own pictures, you know, because I can't find it online. Yeah, I want to see the phase plot of, well, you got the Fibonacci, I mean the other number, and that's actually a two-dimensional picture projected on it's a three-dimensional picture projected on a two-dimensional plane. I don't know, I think I'm getting too involved in it, and I need to do other important things this week. So yeah, have a good one.